At the last video, we know how to find the modular arithmetic of a fraction. So at this video, we're going to dive deeper in the first method. So the first method, this is the arithmetic method. Okay, arithmetic method. So at the arithmetic method, the first method, we have some relationship with the Euler's theorem. So first let's think. First we're using intuitive, and let's see. And as the last video we talked about, that we can change this to bx because we both side times b. So it's bx and then congruent a mod n. So we know. So if we write like this, so we have b times b to the negative 1 and then times a, and then that's congruent a mod n. So actually we think that we're gonna let x equal to b to the negative 1 times a. So the equation is like this. So that means right here b times b to the negative 1, and that's 1. So it's 1 times a, so it's a. And a, of course, is congruent a mod n. So right here we know that sometimes b to the negative 1 means modular inverse element. So right here we know b to the negative 1, if it just means a fraction as 1 over b, so it's if x choice this, then x choice b to the negative 1 times a. So that's no meaning because it just the same was right here. It's just a over b, so it's no meaning. A over b congruent a over b mod n, that's no meaning. So that means b to the negative 1 should be choice an integer. Okay, and then this part we will talk about later in this video. So now let me prove something else here. So we know that we write down the Euler's theorem. And the Euler's theorem is b to the 5 n, and then congruent 1 mod n. So right here we know, and the condition is n and b and n need to be co-prime. So right here in the last video we had talked about right here the condition in the fraction problem right here. B and n must be co-prime. Okay, so of course it's satisfied, right? Okay. So this is all the certain theorem. So now we're gonna do so that means n is the divisor of b to the 5 n. And the whole thing minus n. Okay, sorry, minus 1. Okay, doesn't mean this one. Okay, this one. So what does this one mean? That means b to the 5 n, and then minus 1. Okay, and so this is equal to ny. So move right here and move this right here. So we have b to the 5 n, and then minus ny equals 1. So if we just change it to a part, and we apart this thing, so we have b times b to the 5 n minus 1, and then minus ny equals 1. So right here we know this form is just same like the Bizet identity in this problem, because the Bizet equation in this problem, because we know the Bizet equation in this problem is bx minus ny equals 1. Okay, I don't write it right. Okay. So right here, of course we see here. So that means b to the 5 n minus 1 here is 1 root of x. Okay, and so now we know that b to the 5 n minus 1 is a root of x. So we're going to do that. So we know that b to the 5 n minus 1. Okay, of course we know. And the b to the negative 1, this b to the negative 1 is a modular inverse element of b to n. And we know this modular inverse element, of course, this modular inverse element, we know we can calculate it using the Bizet equation, and actually this value is also a root of x right here, because we know this Bizet equation is bx minus ny, and then equal 1. So so it's congruent to b to the negative 1, and then mod n. So I've used algebra to prove it, okay? So now let's go back to see it right here. So this is intuitive. Okay, in the intuitive right here, so let's think here. We had talked about earlier right here, we know that between -1 can be represented by a fraction or an integer because this is in the modular arithmetic. So okay, so right here we're going to do is we both side times the between -1 in this Euler's theorem, right, so we have b to the 5n right here, it's times b to the -1, and then congruent b to the -1, and then mod n. Okay, right here we have this equation right here, and we can let the left side, the b to the -1 on the left side represented by a fraction. So we can and then the b to the -1 in the right side, on the right side, so we can represent it by an integer right here. So that means if right here it's in the left side, if it's represented by a fraction, so we can use the exponential rule, or maybe like exponential rule, right? And we can combine. You see, we can combine the exponential. So we have b to the 5n and -1, and then here is just an integer. So it's and the congruent b to the -1 and mod n. Okay, so the intuition makes sense. Of course, we also can change the right side, right? B to the -1 on the right side, we change it from an integer to a fraction. So that means we have so we can notice right here is that a number congruent. We also can congruent a fraction mod number. I mean the modular arithmetic. So now at last we can pick the transcendental theorem out of memory right here. So we know, of course, you will remember if you watched my video before and of the transcendental theorem. So we know that transcendental theorem is we have some terms like here, a1 maybe times t1 and maybe times uppercase m and uppercase mi. So we know. And so right here with T1 right here, this is a modular inverse element. Right, so we have a T1 right here. So T1 only can be an integer, can't be a fraction. Why? It only can be an integer. So if it's a fraction, so it will be cancelled out. It will be cancelled out with the uppercase mi right here. So every term can't be a multiple of the lowercase mi, or of course, except the term that you choose.